Hello, my name is Holly Cheng and I am a student in the Electrical Engineering Department at the University of Michigan. This summer I participated in a summer undergraduate research experience under the direction of faculty advisor Professor Guo and postdoc Hyung-Won Baek. My project was on finding applications for a new ultrasound generating device. The key advantage of this new device is the specificity with which it can use ultrasound to target an area only a few hundred micrometers wide. The main project I worked on was investigating the application of this ultrasound generating device to sonoporation, the use of sound to temporarily open a cell's membrane to allow uptake of drugs, DNA, or other nanoparticles. Sonoporation is often used in gene therapy. The exciting part of this new device is that we can specifically target a few cells for molecular uptake, unlike traditional methods which affect a much wider area. The mechanism of cell permeabilization is that ultrasound causes nuclei, microscopic bubbles in the liquid, to grow exponentially. The bubbles then violently collapse in such a way as to form tiny jets, which hit upon the cells and are believed to cause the membrane to open. To test if this device generates ultrasound that could cause sonoporation, we used cells cultured in medium that contain potassium iodide, or PI. PI is a fluorescent molecule that selectively stains DNA-enriched organelles such as the nucleus. It normally cannot enter cells. After the ultrasound device is used on cells, they can show uptake of PI due to sonoporation. The uptake can be visualized by looking at the fluorescence emission from PI-stained intracellular components. This is a picture of cells before ultrasound treatment. The blue circle encloses the focal zone of the ultrasound device and indicates the cells that will be affected by the treatment. Notice how the cells look flattened and are close together. After the ultrasound treatment, you can see that there is an empty spot where cells used to be before they were detached by the ultrasound treatment. The cells that remain in the focal zone look more compressed and rounded than before, showing that ultrasound has physically altered the cells' shape. This is an image of the same group of cells, only this is looking at the fluorescence that is emitted by the PI-stained cells. As you can see, there are already a few fluorescent cells, meaning that those clusters of cells are already dead. After ultrasound treatment, you can see that within the focal region, multiple cells have been lightly stained red, meaning that the ultrasound treatment was able to deliver the PI molecules across the cell membrane. Therefore, we have confirmed that this new ultrasound generating device is capable of sonoporation. However, more research is still required, and one problem is that we do not know if the cells that contain PI are still alive or are killed by the ultrasound, and our next goal is to investigate that. This summer was a really good experience for me. I gained lots of exposure to reading literature articles. I got to sit in on lab meetings and learn the ins and outs of research, and I got to see the collaboration between different labs and disciplines. I'd like to thank Professor Guo and the SURE program for providing me this opportunity, and Dr. Baek for giving me his guidance. Thank you for listening, and I hope you enjoyed my presentation.